Today we are going to learn about a topic that is limiting reagent. Now, first we'll start with the definition. Definition of limiting reagent tells that limiting reagent is that reactant which is present in minimum amounts in a chemical reaction. So, that particular reactant, now there might be 1, 2 or 3 reactants in a particular reaction. So that particular reactant which gets emptied first, so that reactant is called as the limiting reagent. Let us learn about it in detail using an example. So let us see this example wherein A plus B gives C plus D. Now it's a balanced reaction. Let's suppose at time is equal to t, when the reaction is not started, I have taken 10 moles of A and 5 moles of B. C and D are not formed yet. So, after time t seconds, what happens? All the 5 moles of B gets utilized and it leads to formation of 5 moles of C and 5 moles of D. So, at time t, all these 5 moles have been used. So you can see here A was 10 moles and B was 5 moles. So if you see this stoichiometrically also, 1 mole of A requires 1 mole of B. So same way, if there are 5 moles of B, it will just require 5 moles of A to give 5 moles of C as well as 5 moles of D. Stoichiometrically, according to the equation, this is true. So I had only taken 5 moles of B. So it uses 5 moles of A, although there were 10 moles of A present in the given reaction mixture, but the amount of B present was 5. So that reactant who is limiting or who is making the reaction come to a halt, that particular reagent, or which is limiting the further process of reaction, that reagent we are calling it as limiting reagent. So in this case, B is my limiting reagent whose quantity was in lesser amount and which was over first. Okay, so if you are comparing A and B, B gets over first, then A gets over. So A remains at time t seconds, 5 moles of A still remains in the mixture unreacted. It remains in the mixture unreacted. So this reactant we are calling it as excess reagent. We call it as excess reagent. So we have got 2 words here. In this particular reaction we are having, one is called as LR, that is limiting reagent. The second reagent or the reactant is called excess reactant or excess reagent. Now, while solving questions related to LR, what are the things LR is going to decide? Now, LR is the one who will decide, that is limiting reagent is the one who will decide how much of C is formed, how much of D is formed and how much of A is used. So, limiting reagent is the one who is going to decide how much of the product is formed and how much of the other reactant is being used. So, we can also understand this using another example of daily life, limiting reagent. Now, let us just suppose we will just think that to make 1 cup of tea, we require 1 glass of milk and we require 1 tablespoon of tea powder. This is the reaction for suppose. Now, for suppose I have 1 person at home, so I am making 1 cup of tea. For suppose some other day I get 5 people at home. There are 5 people, so I have to make 5 cup of tea. And I only have 1 tablespoon of tea powder, but I have 5 glasses of milk. I have sufficient amount of milk, but I have only 1 tablespoon of tea powder. Now, with 1 tablespoon of tea powder, I can only make 1 cup of tea. Even if I am having 5 glasses of milk, I don't have enough amount of tea powder to make 5 cup of tea. So the amount of tea powder available is only 1 tablespoon, which is just enough to make 1 cup of tea. So whatever may be the other reagents amount, that is of no matter there. So this particular reagent is a limiting reagent here. So this particular reagent decides how many amount of products I can make. So tea powder is my limiting reagent in this particular case. So this is how we learn it using a small daily life example. Now let us see some of the problems, or let us also see how to identify a limiting reagent in the given questions. So that is what we will start. Okay. Suppose let us take a question. We are having one reaction, that is N2 plus H2 giving 2 times giving NH3. This reaction, let's start from this reaction, and it is told I am having 10 moles of N2, I am also having 10 moles of H2. They are asking me how many moles of NH3 is formed. So first what I will do, I will try to find what is the limiting reagent in this particular question. For that, the first step would always be balancing the reaction. First step is always balancing the reaction. We have to balance the reaction. When we balance the reaction, what do we get? It is 2 times NH3, it is a 6. This is what we are getting in this particular case. So that is the first step, that is we balance the reaction. What is the second step is finding ratios. So what is the ratio between, we are doing moles of reactant divided by its reactant coefficient. So this number which we are using for balancing, that number is reaction coefficient here. So we will do that for nitrogen, that is N2. We are having moles as 10, and then reaction coefficient for that particular N2 is 1. So this remains as 10. Second one is hydrogen. Number of moles were 10. That is divided by 3. So this is 3.33. Now, how do you decide which is the limiting reagent? Limiting reagent should have lowest value. When you are putting into this particular formula, when you are finding the ratio moles by reaction coefficient, the one which has the lowest value becomes the LR, that is limiting reagent. So in this case, hydrogen is my LR. So hydrogen is going to decide for me what is the amount of NH3 produced in this case. So this particular question depends on the product, mainly the amount of product formed here depends on hydrogen, because that is my limiting reagent. Now the next question can be, is the question belonging to LR category or not? So how to find that? How do we find that? To find that, what we will do is, we will see reactant ratio and product ratio. They shouldn't be same. So reactant nitrogen reaction coefficient divided by hydrogen, and then product side it is just 2, because the reaction coefficient of NH3 is 2. So for nitrogen it is 1 by 3 and this side it is 2. So they are not equal to each other. If these values are not equal to each other, then the question falls in the category of limiting reagent. So this is what we have to find when questions are given. Find the amount of the product form. Okay. Now this is one part. Now again, how to find how many moles of NH3 ammonia is being formed. Till here the question, the problem remains the same. Okay, we have found out what is the LR, that is limiting reagent. Now taking consideration of the limiting reagent, we can solve this particular question something like this. So this here, 3 moles of hydrogen, this is from the balanced equation, gives me 2 moles of NH3. This is from the equation, the chemical equation. Now according to the question, I have 10 moles. 10 moles of hydrogen gives me how much of NH3? So 2 into 10 divided by 3. So the answer whatever I get, that tells me the moles of, that comes around 6.66 moles. So 6.66 moles is the moles of NH3 formed, that is equal to 6.66 moles. So this is the complete procedure of finding out LR and finding out what is the amount of product formed. So let us just look at it once more. The first step is always balancing of the reaction. So when I balance 1 time N2, 3 times H2 gives 2 times NH3. The second thing is we are finding the mole ratio, that is ratio of moles divided by the reaction coefficient. So for nitrogen, number of moles given were 10 and the reaction coefficient was 1. 10 by 1 is 1, 10 again. Hydrogen, moles given were 10 and coefficient was 3. So it's 10 by 3, 3.33. So out of the two reactants, I check for the lowest value. The one with the lowest value is considered as the limiting reagent. So in this case, my limiting reagent is hydrogen. As discussed earlier also, we know that the limiting reagent is the one which is going to help us to find the moles of product in this case. So here, the next step is to find the moles of NH3 form. I use my LR limiting reagent to find out the amount of product form. So 3 moles of, from the chemical equation, 3 moles of hydrogen gives me 2 moles of ammonia. And as the question suggests, hydrogen given to me is 10 moles. So 10 moles of hydrogen is going to give me how much of ammonia. So it's a simple cross multiplication which gives you 6.66 moles of ammonia as the product. So this is one kind of problem how we solve using the concept of LR. That is more question. The question says there is 0.1 mole of BaCl2. It is mixed with 0.3 moles of Na3PO4. We have to calculate the moles of Ba3PO4 form. So let us first write the equation. That is BaCl2 plus Na3PO4 gives you barium phosphate plus NaCl. After that, we will just balance. So while balancing, as you can see, this is 3 times, this is 2 times, and this becomes 6 times. Now let us just write whatever is given in the question. How much of BaCl2 we are taking? That is 0.1. How much of Na3PO4 is taken? That's 0.3. At time is equal to T. Products are not formed. Now what are we going to find? Find LR. Find LR. Now when I find LR, 0.1 divided by the coefficient, that is 3, which is going to give me 0.033. And next you are having 0.3 moles divided by 2, the reaction coefficient, which gives me 0.15. So 2 values. So now the lower value is 0.033. So this is my LR, that is BaCl2. BaCl2 is my limiting reagent now. Now let us see how much of this product is formed. Now product is barium phosphate is dependent on BaCl2 because that is my limiting reagent. So let's see. As given in the question, equation says 3 moles of BaCl2 gives me 1 mole of Ba3PO4 thrice. The equation says, how many moles of BaCl2 do I have? It's 0.1. So 0.1 mole of BaCl2 gives me how much of Ba3PO4? Cross multiplication and 0.1 into 1 divided by 3. So that's going to give me 0.033 moles of Ba3PO. On the other hand, if we are asked how much of Na3PO4 is used, then how do we calculate? We use the same technique. That is 3 moles of, now the question is moles of Na3PO4. How many moles of Na3PO4 are used? So that says 3 moles of BaCl2 requires 2 moles of Na3PO4. Now I am having 0.1 moles of BaCl2. How much of Na3PO4 is used? So it is 2 into 0.1 divided by 3. So these many moles of Na3PO4 is used during the reaction. So this is how we are going to find amount of other reactant used and amount of products formed of whichever product is asked. This is how we can find. If 54 grams of Al reacts with 160 grams of oxygen, find out weight of the product given. So now if we see here, it is just okay. Now you can see here everything is given in terms of grams. This is one thing what we have to know. Let us start with balancing the equation. Now when we balance the equation, 4 times Al gives 3 times O2 and this 4. It's 2. So this is balanced equation. Now everything here, as I told you, is given in terms of grams or in weight. But this concept is about mole. So whatever in other form, if they are giving you weight, volume, all those things, make sure you are converting them into moles. So let us convert 54 grams of Al into moles. So we know what is the formula we have. Moles is equal to mass per molecular mass of atomic weight. Anything. So in this case it is aluminium. So 54 grams of aluminium divided by 27, it's weight. So that gives me 2 moles of aluminium, and moles of oxygen is 160 divided by 32. That's 5 moles of oxygen. So now when I see, I just put them again. I have written the equation. Al plus 3 times O2 gives Al2O3. 2 moles of Al I have and 5 moles of oxygen. So let's find out what is the limiting reagent. How to find? Moles divided by coefficient 2 by 4, and here it is moles by coefficient 5 by 3. Now obviously we know that this value is smaller than this value, right? So this is my limiting reagent, that is aluminium. So what is given? They are asking us how much of Al2O3 is formed. So let's check that. 4 moles, according to question, 4 moles of Al gives 2 moles of Al2O3. That's given in the question. What now? How many moles do we have of aluminium? That's 2 moles. That is what we have found here. So 2 moles of aluminium gives how much of Al2O3? So that 2 into 2 divided by 4, that gives him 1 mole. Now see the question. They are asking you what is the weight of the product. we have got moles of the product Al2O3. What do we require? Moles. From moles we have to get weight. So 1 mole of Al2O3 is formed. Let us convert into weight or mass. Let us get. So moles is equal to mass per molecular mass. Molecular weight comes up to 101 grams for Al2O3. So moles is 1. So 1 is equal to mass by 101. So mass comes around 10 point something grams. So what are the things to note in this question? If weight is given of any substance or any reactant, make sure you convert it into moles. Second thing is, check what is the answer asked in. Is the answer asked in moles? Is the answer asked in weight? Is the answer asked in volume? So all these things are what we have to take care while solving such questions. 9 moles of D and 14 moles of E are allowed to react. Calculate number of moles of B at end of the reaction if 4 moles of G are present in the reaction mixture. So 4 moles. Now these are, that's told here, percentage yield. How much percent yield is obtained, that is what is told. Now let us start this particular question. So as told, there are 9 moles of D, 14 moles of E. So let us first find what is the LR here. So this is 9 by 3 and this is 14 divided by 4. So which is my LR here? As we can see in this particular values, this is 4 ones are 4 threes are, so 3 point, so 3 ones are, this comes to 3 threes are, this is 3 point something, it's not actually 3, 3.5 and odd you get as your answer, 3.5. So definitely this is going to be my this is my LR, that is D. So D is my LR. So let us find how much of C is formed. What is our final question? How much of B is formed, isn't it? So in order to know how much of B is formed, here also I should find LR. But what do you see here? This is second part. This is the first part of equation. This is the second part of equation. They have not told me how much of C is being taken. So from where do I get how much of C? The product formed here is taken in this particular step. How much ever is the product formed here, I have taken it into the next step. So here I should first see how much of C is obtained. That much of C becomes the number of moles of C here. Okay, so that is the reason why we are finding amount of C in this particular equation first. So let us see here. 3 moles of D is going to give me 5 moles of C. How many moles do I have there? 9 moles of, what is this, D gives me how many moles of C? So this is just 9 into 5 divided by 3. How much do we get? 15, right? Now see properly, 15 moles is obtained when the product is 100% yield. But what is told in the question? The yield is only 80% for this particular reaction. This many moles is obtained when the product is 100% yield. But if I have 80% yield, then it is 15 into 0.8. So what is the answer I get? It becomes 12 moles. So 12 moles of C is obtained in this particular step. So those 12 moles are taken here. Now let's see what happens in the second step. Now I should determine how much of B is formed. Here also this is the second step, but reactants are different. So I should find LR in this case also. How do we find LR? Again the same thing. 12 divided by 3 4 divided by 5. So this comes, so this is my LR here, isn't it? So this value is definitely lesser. So G becomes my LR. So let's again see here. 5 moles of G gives me 6 moles of B, right? And how many moles do I have? 4 moles of G gives me how many moles of B? So it's 6 into 4 divided by 5. Again remember, this whatever is the answer, 24 by 5. This is when yield is 100%. But what is told? Yield is only 50%. So 24 divided by 5 into how much do you get? It is 0.5 into 0.5. So what is your answer around 2.4. So whatever is the answer here, around 2.4 is 2.4 moles. Okay, so this is moles of B formed as the product. So here what are the things we should remember is, what are the points to take? One is, here it is given as what is the percentage yield. So whatever we are cross multiplying and getting, that is 100. That is what we are expecting value. Okay, that's not the actual value, that's the expected value. That's when the yield is 100%. But any reaction is not 100% complete. So the amount of product varies. So in this particular reaction, maximum product obtained is only 80%. So that is why these little changes we have to make by looking at what is the information given in the question. It says 80% yield. So for 100%, if this is the yield, for 80%, how much it is? So that is how you do it. Okay. So this finally, whatever is the mole got here, that is the same amount taken in the second step. So that is the reason why we find moles of C in the first step. Okay. Mass of N2F4 produced by a reaction of 2 grams of NH3 and 80 grams of F2 is 3.56. So this is 3.56 is this reaction they have done, and this is the amount of product which is formed. They are asking what is the percentage yield. Percentage yield formula all of us know. Percentage yield is the actual, that is what is observed yield, what are we observing during reaction, divided by what is the calculated. During calculation you get a yield. So that yield into 100. So this is going to give you percentage yield. Now calculated yield we have to calculate. Actual yield they have given. So our work is to find percentage yield. Okay. So let us start. How to find? So let's write the reaction. As the reaction is written, given already, NH3 plus F2 gives N2F4 plus 6 times HF. So 5 and 2, these are my coefficient. Now what is the next work? Next work is to find out the moles. See, you can see in this particular thing, everywhere they have given in grams. So I need to convert them into moles. So first thing is for ammonia. So 2 moles, they have given 2 grams divided by the weight is 17. So you get 1 by 8, your value here. And here it is 5. It is 80 grams divided by 5. So definitely this value is going to be smaller value than this particular value. That is what decides. That is this here, if you calculate, this comes around 14. So this is 0.11. So limiting reagent for me is ammonia. So this is my limiting reagent. So now I will find moles of N2F4 here. So 2 moles of NH3, 2 moles of NH3 gives 1 mole of N2F4. How much do we have? I'll use this for simpler calculation, that is 2 by 17. I'll keep it as it is. 2 by 17 gives how much? So 2 into 1 divided by 17 into 2. So this 2 gets cancelled. 1 by 17 moles of N2F4 is formed. So now this is moles. I want it in mass. So when to get it in mass, what do I do? Moles I have. Molecular mass comes around 66 for N2F4. So moles is 17. So 1 by 17 is equal to mass by 66. So 1 by 17 into 66. This is going to give you 3.88 grams. So what is the 3.88 grams? This is the calculated yield. I have calculated. If the yield is 100%, then this should have been the value. But it's not. Any reaction I told you will not give you 100% product. So they have told us what is the product for this reaction. It's 3.56. So let's calculate. Percentage yield is equal to actual yield. That is what we have obtained, 3.56, divided by calculated yield. That is what we have calculated, 3.88, into 100. So that gives me around 91%. So this reaction gives you 91% of yield. So this is